We've been talking about alkenes this whole time, but alkynes are in this chapter as well, and alkynes have triple bonds. These are just some facts about triple bonds. Triple bonds are linear. They do not have any cis-trans isomers like double bonds can, and they are shorter than double bonds. We've got 3 pairs of electrons being shared, and that pulls the atoms closer together. They're shorter. They are going to be linear always because of the hybridization around that carbon. Here again is our orbital diagram for carbon. 2 valence electrons in the 2s and 2 in the 2p. And what happens is we're going to bump one of these 2s orbitals up to the p, and then we can hybridize. We've talked about sp2 and sp3 hybridization. This is where we get sp hybridization. So we're going to take the one s orbital and one of the p orbitals and make 2 hybrid orbitals. And that leaves the 2 p orbitals unhybridized, and they're each going to have 1 electron in them. So in yellow, we see the sp hybrid orbitals. There's 2 of them, and so they're going to arrange themselves around the nucleus to be on opposite sides. There's a 180-degree distance between these. The p orbitals that are not hybridized have their regular shape and orientation, and so one of them will be perpendicular vertically and one will be perpendicular horizontally. The sp orbitals can overlap end to end and form a sigma bond. And then we have 2 p orbitals, 2 on each carbon, that can form pi bonds by sideways overlap. And so that's how we end up with a triple bond. So the p orbitals and one of the sp orbital are involved in the triple bond, and what's left is the other sp hybrid orbital, which is going to overlap and bond with hydrogen or carbon or something else. But we're going to have this linear geometry.